Okay, for our pupils, we're going to be looking at intersection of lines and parabolas. Okay, this is also often referred to as investigating tangency. That's the main type of question that's going to be asked. Okay, so the discriminant previously has been used to investigate the roots of a quadratic, and this time we're going to look at investigating the intersection of a line and a parabola. So a line and a curve, and how do they intersect? And they intersect in three different ways, potentially three different ways. It could be 2 times, similar to a parabola touching our x-axis twice, having 2 distinct roots. A single time, which is going to be the main type of question that's asked, which is a tangent, which is very significant, or it essentially misses completely and they do not touch at all. Okay, we'll investigate 3 different ways, or 3 different types of graph for that, similar to how we looked at our discriminant with our roots. Okay, first of all, our method. The very first thing we're going to do is we're going to substitute the equation of the line into the equation of the curve. So i.e. we're going to say that at a particular point we're investigating when the equation of the curve is equal to the equation of the tangent. So the straight line will be y equals 2, some sort of y equals mx plus c, and the curve will be some sort of quadratic, x squared plus or minus an x term plus or minus a constant term. So 2 y's, and we're going to investigate what happens when they are equal to each other. So that first stage is y equals y. We will then have a resulting quadratic, and that quadratic will represent the points of intersection, and we can investigate what the discriminant would be, and from that we can make a judgment on the nature of the line meeting the curve. Okay, and looking here, 3 different options, and again I'll do very brief wee graph here. So the actual curve's not particularly important. It can be U-shape, it can be N-shape, it can be absolutely anywhere in our coordinate diagram. I've just drawn a very basic U-shape, and if we have a value for a discriminant for this resultant quadratic to be greater than 0, then our line and our curve meet twice. So it would be something similar to that. So at these points here, we can say that y is equal to y, i.e. the line and the curve are equal to each other at those particular points. Okay, so if it's greater than 0, it will meet twice. Again, if we have a second option, so again, curve not particularly important, any old U-shape I've drawn. If we have a discriminant value of equals to 0, similar to what we have with our roots, is that they will just touch at a single point, i.e. at that single point where that curve and that line meets, we can make the statement that y is equal to y. Okay, and then probably what you would expect from the last one, curve, any old curve, and if the discriminant is less than 0, they do not meet. Okay, so there's no point there that we have y equals y. That's investigation, and our resulting discriminant would be a negative value. Okay, the type of questions that you can meet, there's 2 different types. Okay, of the basic question, and then we'll look at question 3 separately in another video. So in questions 1 and 2, there's a slight difference. And if we look here, show that the line y equals 4x minus 2 is a tangent to the parabola. Okay, so you're basically in this one investigating b squared minus 4ac and is it equal to 0. In 2, exact same start, however, the second part of the question makes your approach very, very different. Okay, so I'm going to show you in 1 our basic option with our discriminant, and in 2 we're actually going to do it in almost 2 different ways. So show that the line y equals 4x minus 2 is a tangent to the parabola y equals x squared plus 2. So I've got a line, I've got a parabola. What I'm saying is what happens when they intersect. So at the particular point, the line and the parabola are equal to each other. So y is equal to 4x minus 2. Y is also equal to x squared plus 2. Take away 4x from both sides, gives you minus 2 x squared minus the 4x plus 2. Add 2 to both sides, gives you x squared minus 4x plus 4. Okay, and your basic solution will give you an investigation for b squared minus 4ac. So we have coefficient of x squared, coefficient of x, and constant value of the resulting quadratic. Because this is when we investigate where the lines meet and not the roots of the original quadratic. So a is 1, b is minus 4, c is 4. The numbers certainly look as if they're going to work out. B squared minus 4 is equal to minus 4 squared minus 4 times 1 times 4. So we have 16 minus 16, which is equal to 0. The fact that the question stated show that you have a tangent, you were expecting 0 to come out. If you didn't have 0, then something was wrong. Okay, statement-wise, very similar to how we would have communicated previously. As b squared minus 4ac is equal to 0, that's what you found. And taking the information from the question, the line y equals 4x minus 2, and you're showing that it's a tangent, so is a tangent to y equals x squared plus 2. And we get our values from that. Okay, that's our typical type of question. In this second one, we'll approach the first part the exact same way, and we'll show you we can get the actual solution from that, but our main solution is going to actually be driven from this second part. This second part, where we have to state the coordinates of the point of contact, you have to factorise and solve. To find the point of contact. Okay, and you can actually factorise and solve to answer the first part as well. Okay, so let's have a wee look just using our discriminant first of all. So I'm going to do the common bit of the solution in blue, and then I'll split the second parts in the two different colours. Okay, so again, if we're showing that as a tangent, we're saying, well, what is happening when y is equal to y? and our first y is y equals 1 minus x, and that what's happening when it's equal to x squared minus 3x plus 2. We'll add x to both sides, and take away 1 from both sides. Okay, so I've got my resulting quadratic. So option A is use discriminant. So exactly what I did in the previous one, I'm going to take in the value of the x squared out as 1 minus 2, c is 1, b squared minus 4ac. The fact is I show that I'm expecting 0 to come out of this. Minus 2 squared is 4 times 1 times 1. 4 minus 4 is equal to 0. So exactly the same as previous, as my b squared minus 4ac is equal to 0. Then what that means is the line y equals 1 minus x is a tangent to y equals x squared minus 3x plus 2. Okay, that answers the first part. However, you're a bit of a situation to try and get the coordinates of the point of contact. Therefore, your option 2, or option B, sorry, factorise and solve. So from there, again, we're just going to use our resulting quadratic. Factorise and solve. The only way I can get x, the only way I can get the 1, and then it's a minus 2, so both of them have to be negative. And both those brackets the same, so as x is equal to 1. So what I've found here is the x coordinate of the point of contact is 1. But the fact that I've also got to that stage and there's only a single solution, I've actually proved the first part of the question as well. So I've shown that the line and the parabola only meet at x is equal to 1 at no other point. So I can actually communicate my answer and answer the first part of the question. So as there is a single point of contact at x is equal to 1, because I've found that out, I can say that that line has to be a tangent to the parabola plus 2. And why that's significant is I would have to factorise and solve anyway to do my next part. So the solution in blue is the more economical solution essentially. It's going to involve the less work as opposed to using your discriminant to factorise and solve and then do our substitution of our x is equal to 1, y must equal 2. Well, I've actually got two options. There's one option for y, there's a second option for y. I can put 1 into either to be able to get a y value out. Pretty much every single time you're going to put it into the straight line. So 1 minus 1, which is equal to 0. So at that point, sub into either line or parabola. So to answer my final part of my question, the point of contact is 1, 0. So the solution in blue is a full solution. That answers both parts of the question. In black, answers the first part, and you would have to use part of the blue solution anyway. But either way, we have communicated our answer for the first part using that with the evidence above, or there with the evidence above. That communication is absolutely key. Okay.